Advanced Financial Modeling, Topic 7, Option Valuation and Hedging, Learning Objective number 2. We're going to value options using the Black-Scholes model. We're going to value this particular call and put option on Google. At the date, Google was selling for $614.27. That's the underlying asset, the underlying stock. And what we're going to look at is valuing the 615 call. So we can call that the at-the-money call and the at-the-money put. This is a common way of displaying option prices where you have calls on the left and puts on the right. And what you see is this is a March 17th maturity date call, and the current date was February 28th, so it's just about a little less than a month to go before it matures. And we're also looking at this March 17th 615 put. The calls are selling around $9 to $10, and the puts are selling $10 to almost $11. So what we're going to do is that's the market prices. When I say around those prices, I'm looking at the bid and ask prices. Those are the current indications for the price to buy or sell the option. So what we're going to do is we're going to try to value the option using the standard Black-Scholes model. So Black-Scholes is a model or theory and accompanying formula to compute the value of a call or put option. Black-Scholes assumes that returns are normally distributed, so bell-shaped distribution, and volatility is known and constant. So you know what the expected standard deviation of the underlying asset is going to be, and that's not going to change over, say, the next week or month or year. Black-Scholes is the standard model for valuing calls and puts, even though the assumptions are normality, normal distributions, and constant volatility are widely criticized. So here is the formulas. Here's one for calls, and here are puts. These are VBA functions. Just to give you an idea, BS call and BS put have these parameters: the underlying spot price of the asset, so that would be today's price of, say, Google. K is the strike price of the option, say 615. V is the annualized standard deviation over the life of the option. R is the risk-free rate over the life of the option, annualized. T is the maturity of the option in years, and D is the dividend yield. BS call and BS put have the exact same parameters. And you can see it's a bit complicated, but Black-Scholes requires you to calculate something called D1 and D2, which rely on the comparison of the strike price and the the risk-free rate and dividend yield and volatility of the stock. And so you calculate something called D1. ND1 is a normal distribution probability, kind of like a z-score. And so if you have D1, D2, ND2, and then you calculate BS call. And the same idea with BS put. Okay, so these are the functions. We're going to go into our spreadsheet, which they're already in a module in your spreadsheet, so don't copy and paste them. They're already there. And we're just going to insert BS call, BS put. And we're going to assume that the volatility for these two options I showed you earlier is going to be 30%, which is about what it's been running at the time I looked at these. Options. In other words, that's what it's. If I looked at this last couple of years of returns, it's been running about 30% volatility of returns of Google stock. So the other parameters. These two options. Today's date was February 28th. And these options mature March 17th, which is 13 business days. So I take a fraction of 13 over 252 business days of the year, and the maturity I'm going to use is 0.05 years. That's going to be the T. I also need to know the underlying stock price. That's going to be my S. The strike price of the option, that's going to be my K. The dividend yield is my D. Interest rate is R. Volatility is V. And we're going to go ahead and insert those two functions right now. Go to our spreadsheet. If I hit Alt F11, you can see BS call and BS put are up here. So that allows me to just insert them right here. I'm going to put in BS call, user defined. Ask for the spot price of the asset. That's 614. The strike price of the option, that is 615. The volatility, 30%. The R is the interest rate. At the time, the treasuries are 0.1%. Maturity is 0.05 years. And then I'm going to go down one more. You have to slide down here, hit tab, and the dividend yield for Google at the time was 0. Hit OK. I get a $16.36. I'm going to select all of this function, hit F4 to anchor all the cells. I'm going to copy it, and I know BS put has the exact same parameters and the exact same order, so I'm going to change this to BS put. So according to Black-Scholes, the call should be selling for $16 and the put should be selling for about $17. So that was valuing calls and puts using Black-Scholes and a very brief introduction to the Black-Scholes model. In the next topic, we'll talk about implied volatility and what that implies for the Black-Scholes model.